we will then kind of provide a review. So let's see what this hint says here. Hint. Remember to write two equations. So x minus 1, absolute value of that is equal to 5, is x minus 1 equals 5, and x minus 1 equals negative 5. So remember, absolute value is how far away from 0 are we? It's a distance. Or how far away from a point are we? It's a distance. Okay? So if it's a distance, if you're using a number line, you can have a distance to the left and you have a distance to the right. That's why we have to write it as two different equations. So this first problem here would be n minus 8 equals 4 as one of our problems. What's the second problem?
N plus 8 equals 4.
No, look at the hint. N minus 8 equals negative 4. So take a look at the hint. So make the simpler of the sides opposite value. Okay, and then solve it. I would add 8 to both sides on either equation. So I get n equals 12. And this one, if I add 8, I get n equals 4. So I have two different answers that come up. Okay, so let's move this hint over down here. So, what about this one? How would I rewrite this as two different equations?
B minus 5 equals 1.
Or b minus 5 equals minus 1.
There you go. So you got those two. So I'm going to add 5 to both. So I get b is equal to 6. And I get b is equal to 4. Is it 4? Is that right? So again, there's two different answers that result. And again, it's because we're talking about a distance that you have to create two different problems. So you have a point on the number line. How far is it this way and how far is it this way? And again, a distance is always positive. What about down here? I get 4z plus 2 equals 10 and 4z plus 2 negative 10. Solve each, so I'm going to subtract 2 and then divide by 4. Here I'll subtract 2 and divide by 4. Get that. So you're two different answers. Bless you. Recall this a little bit, I hope.
Wait, but how can you, didn't you say that the distance has to be positive?
What?
You said that the
No.
distance has to be positive.
It does.
Then how can you?
No. That's not the distance.
Oh.
That's just what you would have to plug in to get an equal distance on each side. This is the distance.
Okay, all right.
Right here, right there. So 4, 1, 10, 7. Now those are the numbers you have to plug in to be that far away. And it can be negative, you're right. But as far as 4, 1, 10, and 7, those are all positive distances, right? Make sense? Which that's going to be a subtle hint for something that's yet to come. All right, let's go. Let's just move that back over there. Don't need that anymore. All right, so this is t plus 5 equals 7. 2 plus 5 equals negative 7. And subtract 5. Subtract 5. Done. Oh, I forgot to circle this one, I guess. Seem okay? Everyone stuck? Anyone with us? Okay. Everyone taking some notes a little bit? Anyone goofed up on the day because we're starting a little later than normal? Well, so I slept an hour and 15 minutes longer today than I do on most Wednesdays. I didn't wake up at 4. I woke up at 5:15. Woo! Yeah, my med class starts at 6. I get here by 5. No, it's great. There's nobody on the road driving to school. All the road rage people are still sleeping. It's awesome. I love it. So, of course, driving this morning, I saw some of the fruitcakes. But all right, can I move on to the next page? Cool. So now we're going to start. So we were just solving absolute value, but now we're going to be graphing absolute value functions. So we've graphed linear functions, and we learned a couple of methods. There's standard form on graphing where we can cover up the x and the y using the cover method to figure out where we're crossing the x and y axis. We talked about point slope form. where you have a point and a slope, and the slope defines you a second point. So it's a map. And then there's slope-intercept form where you find the y-intercept, and then you use the slope from there in order to move on. So now we're going to be graphing absolute values. And absolute values, the nice thing is, they are straight line graphs, but absolute value graphs look kind of like a V for the most part. Or sometimes they could look like an upside down V. Okay? So it's basically two straight lines coming off a common vertex. So let's talk about that. How do the values of, so our general equation is g at x is equal to a, absolute value of x minus h plus k. So how do the values of a, h, k affect the graph of an absolute value function? But we shouldn't know that yet. This is what we're going to get to. We're looking at where we should get, what kind of information should we know. So we are going to figure out what this a value does to an absolute value. We're going to figure out what this h value does and the k as far as the graph goes. Okay, and there's things that can happen to a graph. A graph can move up and down. It can move left or right. It can be fat or skinny. Agree? Does that make sense if I said that? So there, I bet you that these letters all have something to do with that. And the neat thing about that is once you kind of have how these letters are, it's the same type of reaction to all other non-linear equations. Okay? So this is what we're going to get to. We're not there yet. We should know what this means, and that's okay. Okay, core concept. An absolute value function is a function that contains the absolute value expression. The parent absolute value is function at x equals absolute value of x, and the graph of f at x is absolute value of x is V-shaped, like I just said. In this case, it's symmetric about the y-axis. The vertex is the point where the graph changes direction, so it comes from going down to going back up. And in this case, it's 0, 0. The domain is, I can plug any, so if I look at this, so let's get a term that you might be going, what the heck does that mean? Parent function. What would parent function mean?
The big function.
Okay, the big function. So let's take a quick glance back. So this is this right here. This right here. This is what the graph looks like. You with me? Now what are we getting to? We're getting to, if we go back to this, look at this function though. There's a lot more junk taking place, isn't it? But if I look at this one, I don't have all that extra junk. I don't have an a value. I don't have an h value. I don't have a k value. So the parent function is the most basic form of the function that we're going to go with. And as far as the domain goes, if we look at the graph, I can go from forever this way to negative infinity to all the way to positive infinity, and this graph is going to continue growing. Meaning, in this case, if I'm cruising along this way, if I'm looking up, I'm seeing the graph. If I get to here, oh, it's right in front of me, and then I keep looking up and I can still see the graph. If I look down, I can't see the graph. But if I continue looking up, I can see the graph. So our domain is all the x values, which is going to go all real numbers, which we could say is negative to positive infinity. Okay, but the range, if we're on an elevator going up and down, if I'm way down here, I'm not seeing the graph. I look out left or right on my elevator. But when I get to here, I can start seeing the graph. And I still look out to the left and right, still look out to the left and right, and still see the graph. So my range is going to go from 0 to infinity. So remember, the range is the y direction, the domain is the x direction. And that's a whole lot of information right there, but this is kind of like the fancy way of putting it. Do we feel okay? Okay, so far all we really need to know is the parent function looks like the letter V. The domain is I can plug any number into x and get a result out. I can't, but if I plug certain numbers in for x, I'm not going to get anything that is smaller than 0. I'm not going to get any negative numbers. Okay? So our range. So remember, range goes up and down. Domain goes right and left. But we'll talk more about that. Okay. So we don't have to really work with a partner, but let's see. Match each absolute value with its graph. Okay. these 6 graphs. We can see enough. Okay, hang on. I bet you we can do this. So we know, I'm going to put one extra graph up here. I'm going to go g at x is equal to the absolute value of x, which is this graph. So that's our parent function. And everything else here is shifting our graph around. Does that make sense? So let's think about things that would make our graph shift around. Any thoughts what this might do? Minus 2. So minus 2 is inside the absolute value. Agree? I don't know. Let's think of this. Okay, let's think of this. Rom, hang on. I'm going to answer it, okay? I know you're excited. I know you're excited, but you're probably going to answer it incorrectly, so I want to make sure I get this concept, okay? I know you're excited, pal, and I love you for it. So would everyone feel okay that this graph here, looks similar to this, but it might move up, down, to left, or right?
Yes.
What about this one? Would everyone feel that this graph is going to look similar to this, but this one might have 2 different things? This has one thing that's happening. This has 2 different things. And what about this one? This only has something outside happening, so that only has one thing. And this one has, again, 2 different things happening to it. This has one thing happening to it, and one thing happening to it. Okay, wait a minute. So the general equation is this. And this is what we're going to get to. So the H, the K, and the A, and it doesn't look like we're dealing with any of the A values up there. Can everyone realize what I'm saying when I say the A value is not up there? Does that make sense? Everyone make sense? There's not an A value on any of these? No, there's no Y up there. Does everyone agree there's not an A value up there? Okay. What the A value does, I'll tell you that right, as a precursor, we'll probably get to a slide. A value makes it either really skinny or really fat. So the A value changes the size of it, makes it really skinny, makes it really fat. Okay? But we don't have an A value up there. So should all of our graphs look about the same fat or skinniness? Does that make sense? So let me say that one more time. The A value will control how fat or how skinny our graph is from the parent function. We don't have an A value up there, so all of our graphs should be the same fatness or skinniness. Okay? Now, if I look at some of the graphs, it looks like number 1 has shifted down. How many units does that look like? 2. 3. Does it look like it shifted down 3, that very first graph?
Yes.
Everyone okay with me if I say that? Okay, what about problem number 2? Does that look like maybe 2 things happen to it? It shifts to the right how many? 2, and it shifts up how many? 1. Okay. What about graph number 3? Did it shift right and left or up or down? Right. How many? 2. What about number 4? Shift right, left, or up or down? Up how many? 2. What about problem number 5? Shift right, left? Left. Did it shift up or down?
Nope.
Nope. What about number 6?
Up and right.
Is it?
It's up to
So shifted to the right 2, and it shifted up. 1, 2, 3. Shift up 3. Yeah. Okay, so let's write what we see. Okay. Shift down 3. Is that okay? Is that verbiage that everyone would feel comfortable with? What about this one? Shift right 2 up 1. Is that verbiage that would make sense to you? Shift right 2. Make sense? Shift up 2. Shift left 2. shift right 2 up 3. Is that what we decided?
Yeah.
Okay. So again, I'm just putting words that I think would make sense with all of you right now. I'm not asking you right this very second to say, okay, now let's match A, B, C, D, E, F to 1, 2, 3, 4, 5, 6. I'm not asking you to do that yet. Okay? So, next thing I want us to think about is this. This one, and this one are unique because two things happen to it. Yep, shift right, left, shift up, down. Correct? Does that make sense? And so up here, letter B has two things it's doing as well as letter D. Now take a look at those equations. Okay? Do you feel that you would feel good about yourself saying, you know what? I could see that equation B probably has two things that happen to it because I have an absolute value x minus 2, it's not just x, and I have a plus 1 on the outside. So two things could happen to that. And then letter D, two things are going to happen to letter D as well. Okay, it's going to shift right, left, and it's going to shift up or down 3. Okay, so let's think about this. Problem number 2, it shifts right 2. Well, that could be B or D, correct?
Yes.
But it shifts up 1. What do you think, by deductive reasoning, what do you think we could say the answer for letter B is? Which graph would go with it? Number 2? So I'm going to say that this and this are the same. Okay, let's take a look. Let's just make things work because we only had certain numbers. So graph number 2, I'm showing a shift right 2, and I'm showing it went up 1. But then on letter B, I know that two things are going to happen. 1, because I told you, and 2, let's see, right 2, up 1. I totally get the up 1, but right 2, that's positive, right? All right, so wait a minute. The plus 1, everyone okay with me on this whole up 1 thing?
Yeah.
Anyone else looking at equation letter B and graph number 2 going, you know, this whole shift up 1 thing doesn't make sense to me. And I think the shift of going up 1 probably is pretty obvious. But I'm shifting right 2, and inside, wait, I gotta make this work. It seems to be, I have x minus 2, but you're telling me it shifts right 2. Wait a minute, you know what this relates to? Y'all want to know what this relates to? Think about the point-slope formula. Which was this, right? I'll do it in a dark enough color, hopefully you can see it. Of course, it's fading.
Oh, yeah. X minus x1.
What happens?
Opposite sign.
These are opposite, right? Right?
Yeah.
Remember?
Oh, no.
Remember? Does that make sense?
Yeah.
So, if this inside the parentheses is opposite values, would it make sense that this is an opposite value?
Yes, because the two things.
So something that's grouped is going to do the opposite of what you would think it would do. Make sense? Remember our point-slope formula. Y minus y1 equals m times x minus x1. So our points, when we plug them in, are always opposite. Remember that?
Even the positive is going to be opposite.
Yeah.
Okay.
So let's take a look. Hang on. Let's take a look at letter D. Letter D. What do you think this one's going to do? It's going to go. What do you mean? Which direction? Right 2 and
Up 3.
right 2 and up 3. Right 2 up 3. This is equation D. Okay. Okay, hang on. I think we might have a small breakthrough here. We might have had a small breakthrough. Okay, so on the outside of the absolute value, that's going to dictate whether the graph itself goes up or down. It's going to go up if it's positive. It's going to go down if it's negative. If it's inside the absolute value, it's going to go the opposite of what we think. So if it's a minus, we're going to go right. If it's a positive, we're going to go left. Okay. Problem number A. Number A. It's going to do what to? Right to? Right to? Is there any of those that go right to?
Number 4. Or no, not.
Oh my God.
Sorry. I thought.
Wrong.
Ron doesn't have his ups and downs, right and left downs. So is this A?
Yeah.
Okay. What do you think this is going to do?
Go down 3.
Just down 3.
Down 3? Any of those?
1.
We already got that one. What about this one? What's this going to do?
Up 2.
Up to?
4.
So what's that? E? Up 4? What about here?
Left 2.
Left. Opposite, correct? Left 2?
5.
Okay, so not knowing a heck of a lot to this, we took a prior knowledge of our point slope, which we work on, and we realized something happens to an opposite. And we all related this to our parent function, which is over on the far right in green. G at x equals the absolute value of x. That's the most basic absolute value graph. What did I say the A did?
Slope.
Yeah, it makes it fat or skinny. Good, I like it. Slope, that's a great term. The H shifts it right or left. If it's positive, it shifts left. If it's negative, it shifts right. The K shifts it up or down. If it's positive, it goes up. If it's negative, it goes down.
So is the H and the K a numbered point? Or?
Yes. 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 Good. It's called the vertex.
Oh,
Okay? So, let's jump to what Rom said. Is HK. We're going to call this our turning point, which later we'll start calling a vertex. Okay? It's where the graph changes directions. So what's the vertex here? It looks like 2, 1. Right 2, up 1, 2, 1. What's the vertex here? 2, 0. What's the vertex here? 2, 3. What's the vertex here? Negative 2, 0. What's the vertex here? 0, 2. What's the vertex here? 0, negative 3. Wow. There's a lot of information we have on this screen. Holy cow. And I bet you this isn't the only time I'm going to go over it. Because there's like thick, rich stuff for us. Okay. Can I move forward? I think maybe we could start clearing a few things up, but we did a lot. Yes,
I just have I'm kind of confused with A and F because F is a positive 2 and A is a negative 2. So I was just kind of confused about where they are and all that.
Okay. So this A, because it's opposite, will shift right. That's positive, will shift left.
But everything else is the same as.
So if it's grouped, just like on our point slope, if it's grouped, it's going to have the opposite number. So remember this on our point slope formula? X1 comma Y1. If we had 2 comma 3 as our point, it would become Y minus 3, X minus 2. So it's opposite when it's grouped. And grouping can be an absolute value sign. So we're putting it together. So shift right to, shift left to. They look identical, except they're shifting one way versus the other. And it's always going to be opposite the way it's grouped. If it's not grouped, if it's just kind of hanging by being added or subtracted outside of the grouping, that just goes up or down. Okay? And then the A makes it fat or skinny, like the slope. All right. Oh, wait. Didn't we just say this?
Yeah.
Didn't we just say this?
Yeah.
Oh, boy. What do you notice about the 2 lines from all the previous graphs? They all had the same slope. They all had the same slope. Same steepness. Let's go with that. Did I spell that right? Or is that an A? Steep?
No,
Steep.
is
E-E-E? E-E? steepness. Okay, because it's not necessarily the same slope, because if I have two slopes doing this, one's positive, one's negative, right? But they have the same steepness, this would be the same slope. If being they're like this, that's two different slopes. Okay. Slope. So slope is the steepness of the graph.
Wasn't the slope 1 though?
On those, yes. Absolutely. But it was 1 in one direction and -1 in the other, because it was going down and then up.
So we can say that the absolute value of both of them.
The absolute value. Man, Rom, you are on. Is that the next slide? Did you peek ahead? It's okay if you did.
I cheated.
All right.
Ooh,
It's okay. All right, compare these to the graph. So the graph, I'm going to make this, I'm going to do this blue. Is that okay? So this graph, blue, is going to do this. Okay? Parent function, right? What is this one going to do? We just talked about what's it going to do.
Up 3.
Up 3. So the vertex is going to go up 1, 2, 3. And it's going to have the same steepness. Uh-huh. That's it. And the slope is up 1, right 1, up 1, right 1, up 1, right 1. Or left 1, up 1, left 1, up 1.
Is there ever like a certain
Okay.
kind of slope?
We might change it. So I'm going to again graph our parent function like this. Okay, that's our parent. That's the basic one, right? Okay, so let's do this. What do you think this one's going to do? Right 2. So 1, 2. Same steepness. That's all it's doing. There you go. So, if it's grouped, it's going to shift the opposite direction you would think. If it's negative, it goes right. If it's positive, it goes left. If you're adding something outside the grouping or outside the absolute value, it'll shift up if it's positive, it'll shift down if it's negative. How are we feeling? Feeling all right? Where are we? We're there. Okay. May I move on?
Yes.
Okay, we got a lot of information covered. Ooh, okay. So again, I'm going to take my parent function. This will be blue. So I'm just going to draw this in like right here. Okay, and I'll draw it in here too. Okay. What do you think this one's going to do?
Down 1.
Down 1. What do you think this one's going to do?
Left 4.
Left 4. Sweet. Huh. So the parent function is the most basic of an absolute value. Doesn't have any shifts right or left, or up or downs, and has the same steepness with the slope of the absolute value of the slope would be 1, which I like that term. That's good. Can I move on? Cool. All right. Oh. Hang on. Did we call? Oh, wait. Oh, wait. We forgot this, and I gotta go here. Uh-oh. What? Okay. The green one. Will it go forever right, forever left? Have a graph above us. So what's the domain?
Negative infinity to infinity.
Negative to positive infinity. What about what's changing with the range? Where does the range start? At what?
0.
No, where's the range start on the green?
3
3.
to infinity. Including 3.
Including 3.
Oh,
Okay, hang on. All right, so the domain here on the purple. Go up forever right, left? Negative to positive infinity. What's the range doing?
0 to infinity.
Ooh, why is that one 0? It shifted, but it didn't shift up or down. So the range is going to go from 0 to infinity. Okay? So the domain, as far as our parent function goes, negative to positive infinity. The range of our parent function will go from 0 to infinity. So look at this. The domain and range of the parent function, if it shifts right, is the same. The domain and range of the parent function or the function that shifts up, the domain stays the same, but the range changes. The range is the elevator. I don't want to go with saying always.
Does a roommate?
Okay, just hold on, because it's real dangerous in math to say always. Because on a true-false question, if I were to say this always takes place, it's always got to be false. Because there's always something way far off in math, so I can't say always.
Wait, does the domain ever change though?
Zero?
Huh?
It's like over something, like it's not on zero, but it's over.
If it shifts to the right, your range will be 0.
Oh, it's still zero.
Yeah, because think about what the horizontal axis is, or the x-axis. It's the line y equals 0. So y is your range. So it's always going to start from that and go up.
All right.
Okay? Yeah.
Does the domain ever change?
I'm not going to go there.
Okay, alright.
Okay, just explain that because you can't say always in math because some math class way off in the future, it's going to be different. Okay, so I can't go that, and I'm not going to give you specifics because it's 8 years from now. Yeah, I can't do more. Okay?
Yeah.
Most of you won't get to those math classes, which is fine, but I don't want to influence your thing going, I had a freshman, sophomore level math class in high school said, dude, and then the guy with the PhD in math says, he's wrong. All right, domain. What do you think for the red? Domain for the red.
Negative infinity to infinity.
Negative infinity to infinity. Range,
-1.
including -1 to
To infinity.
square bracket includes, right? What about number 4? Domain.
Infinity to infinity.
Negative infinity to infinity. Range.
0 to including 0 to infinity.
Perfect. Square bracket. Oh man, we're doing well.
Why is it 0?
Think about it. It just shifted this way. So where are we starting from? This is the line y equals 0. So it starts at 0 in the y direction. Yeah.
Never mind. Or actually, so when it goes all the way down to where you can't see it on the x-axis, like if you're walking and you look down, you can't see.
So here, as far as our domain.
Yeah.
So if I look up, down, or on the line, I'm always going to see the graph.
So when would it not be negative infinity to infinity? That's what I'm asking.
Let's not worry about that yet.
Okay.
Cool? We'll get there eventually. In 8 years. Dude, I'll be not here anymore. All right. Graph each. Which value now are we changing? Which value are we changing? The slope, the A value, right? Okay? So, I'm going to graph this. We'll do this in red. I'm just going to draw one. Okay? So, I'm going to try and do it the best I can. So this is the parent function, which is growing at a rate of 1 over 1, whether it's growing to the right and up or to the left and up. Does that make sense? This is going to grow a rate twice as fast. So it's still going to be here, but this is going to grow twice as fast. So I'm going to go up to right 1, up to right 1. So look at this. That's making it skinnier. So as this value becomes a larger number, the graph gets skinnier and skinnier and skinnier because it changes the pitch of it. And you look at it literally like, okay, if I were to start here, I'm going to go up to right 1. I'm going to go up to left 1. That's that. Thoughts? If it was just half, fatter or skinnier?
Better.
Fatter. Now what's this negative out front do? Oh boy. What is this going to do?
Oh, it goes opposite.
Yeah, this is going to makes it go down. It flips down. Okay? It's gonna be fatter because it's half. Okay? So watch this. So it's gonna open down, so I'm still gonna be here. And I'm gonna go
Down 1 over 2.
down what?
Down 1, because it's negative.
It's
Oh yeah, it's negative. Down 1 over 2.
Down 1 over 2. Same here. So does everyone see that this is fatter than our red? Obviously, it's going the opposite direction. So that negative makes it flip to an opposite direction. Okay, hang on. Hang on. So, blue. Domain of blue. Is it going to go forever this way? I can look up, see the graph. Forever this way, look up and see the graph. Negative, positive, infinity. So it's kind of holding what you guys are thinking. The range, starting here, going up. So
including 0 to infinity.
To infinity. All right. Purple domain. If I go, we'll go forever that way and still have a graph below us, and forever this way still have a graph below us.
Yes.
So again, still holding true what we know. The range, though, what's going on? Where's it going?
Negative infinity.
So it's coming from negative infinity and getting to
0.
0.
Oh, yeah.
Ooh. That's coming from way down there. It's coming up from negative infinity, getting to 0 and stopping.
What do you go from 0 to negative infinity?
Goes left to right. Think about where's it coming from? Where's it going to? Okay. Cool. Flip down. Skinny or fat?
Fat. Skinny.
Skinny. Fat. All right, so let's make our parent function. We're going to make it purple. We'll draw both. So parent function. Okay, parent function, right? Do this one here. Flips it down, so it's going down. Still going to start here. So I'm going to go down 3. Right 1. Down 3, right 1. That's pretty skinny. Make sense? What's this one going to do? I'm going to go up 1 and over 4. Over 1. Okay? Domain of blue. Negative to positive infinity. Right? Range. From negative infinity to 0. Red. Domain. Negative to positive infinity. Range. 0 to infinity because it's going upward. Vertex form of an absolute value function. An absolute value function written in form g at x is equal to a, or absolute value x minus h plus k, where a is not equal to 0, is in vertex form. The vertex of the function is hk. We've already talked about this. An absolute value function can be written in vertex form, and its graph is symmetric about the line x equals h. Okay, that just means there's a vertical line and it's symmetric about it, meaning I could fold the graph over that line, the vertical line, and it falls right on top of itself. Okay, so that's a quick core concept. Let's just talk about this. What's this doing? Shifting left. How many? 2. What's this doing?
Down 3.
Ooh. I'm not going to worry too much about this right now. So I'm going to put a question mark, okay? Let's not worry about it. What's this doing?
Left 2.
Shift. What?
Left 2.
Left 2. Oh, it's still going.
Down 3.
Shift. Down 3. Okay? And this is a strange one. This is actually called a horizontal stretch.
How long does that go for?
But I'm not going to worry too much about the horizontal stretch right now. I'm putting the term. I don't think we need to focus on it a whole lot.
Will it be on the test?
I'm holding off on it. Don't panic. I'm just putting the term. That's a little while away. All right. Guys and girls, I will get to the very third page of this. I'll get to the third page. The very back of this, back page, so if you fold it and you make the staple nice and neat, the very back, there are graphs there that you can do. There's 1, 2, 3, 4, 5, 6. So why don't you do page 91, which is on this. You can go look at your book too, or it's the back page of this, and do 1 through 6 for tomorrow. Okay? Cool? Feel good? Newer concept, but I think you guys are starting to grab it. Okay? So I put your homework with the notes for a reason.